We hear the word climate thrown around a lot, but what is a climate zone? Climate zones are regions defined by their weather patterns, temperature ranges, and humidity levels. These zones are used in various industries, particularly in construction, agriculture, and environmental planning, to design and build structures that are suitable for the local climate conditions. They are also one of the general requirements that dictate where and what code requirements should be used to ensure compliance with energy efficiency, design conditions for building materials, as well as systems and equipment. The map of climate zones, which you can easily find on Google, shows the 8 U.S. Building America climate regions based on the designations used by the International Energy Conservation Code and the American Society of Heating, Refrigeration, and Air Conditioning Engineers. These zones influence how homes and buildings should be designed for energy efficiency, comfort, and durability. When looking at the map, on the top you can see there are 3 subzones: marine, dry, and moist. These help indicate the moisture levels in these different regions from east to west across the country. It also helps to tailor the HVAC design to specific moisture and temperature conditions. Now let's talk a little bit more about each zone. In Climate Zone 1, it's characterized by consistently high temperatures and humidity, known as a tropical climate. Summers are long, and winters are mild. This zone includes southern Florida, Hawaii, Guam, Puerto Rico, and the Virgin Islands. Homes here need to focus more on cooling strategies, such as high-efficiency AC systems. Insulation should be thick enough to prevent heat gain, and materials should resist mold and moisture. Due to the high humidity, systems need to control moisture as well as temperature. One of the best ways to do this is with a variable speed system. Proper dehumidification is critical to avoid mold growth. Homes also require well-sealed ducts to prevent the entry of humid air, which could degrade performance or cause moisture issues inside walls and attics. Climate Zone 2 is known for hot and humid conditions most of the year, with high temperatures and significant moisture levels. This zone includes southern Texas and the coastal areas of the Gulf of Mexico. Like Zone 1, efficient cooling is a priority, and managing humidity can be challenging. Same as Zone 1, variable speed systems are one of the best ways to handle the humidity levels. A tight building envelope, well-sealed walls, windows, and roofs is also essential to reduce infiltration of humid outdoor air. In Climate Zone 3, in terms of HVAC design, it is very important to have a balanced heating and cooling system, since significant cooling is required during the summer, but the winter also requires some heating. Also required in Climate Zone 3 is outdoor air. As you get further north, building envelopes need to be tighter and tighter, and because of that, indoor air quality can be hurt. So one way to counteract that is by bringing fresh air into the home. For any climate zone from Climate Zone 3 and up, if your air changes per hour are less than 3, you're required to have outdoor air. And although Climate Zone 3 is less extreme than Zones 1 and 2, moisture management is still important. These states include some parts of Georgia, South Carolina, and the inland valleys of California. In Climate Zone 4, it's a mix of cold winters and hot, humid summers, where it is more balanced compared to the hotter zones below. This zone includes Virginia, North Carolina, and parts of the Midwest. In terms of HVAC requirements, homes need both heating and cooling efficiency, and humidity control is important year-round. Insulation requirements are also a bit higher to maintain comfort year-round, and designs should balance both heat retention for the winter and cooling for the summer. Climate Zone 5 has cold winters with moderate summers. Temperatures can dip below freezing in winter, but remain mild during the summer. States include Washington, Illinois, northern parts of the Midwest. Homes in this zone require more heating than cooling, as winters are cold, but summers are generally fairly mild. High-efficiency furnaces or boilers is the primary focus, typically using natural gas or electricity, but cooling systems can still be necessary for some of the warmer months. Windows should be designed to reduce heat loss, and homes should be built to prevent cold air infiltration while allowing for efficient summer cooling. In Climate Zone 6, they have long, cold winters where temperatures often fall below freezing and snow is common, whereas the summers are fairly short and mild. High-efficiency gas furnaces or electric heat pumps designed for cold weather need to be efficient and powerful to handle the long winters. Heat pumps very often would require additional electric heat strip heating for when they have to run their defrost cycle. Cooling systems are less critical, but still can be necessary for the occasional summer heat. Homes need excellent insulation to retain heat and minimize energy use. Air sealing is vital to prevent drafts, and heating systems must be highly efficient. Windows should be double or triple glazed to keep homes warm. This zone includes northern New England, parts of Minnesota, and Michigan. In Climate Zone 7, such as the northern parts of North Dakota, Minnesota, and Maine, heating dominates the HVAC design. Homes must be highly insulated, and heating systems need to be robust to withstand extremely cold winters, as temperatures can fall well below freezing. Lastly, for Climate Zone 8, it's pretty similar. It's almost entirely focused on heating, and cooling systems are somewhat unnecessary. Ventilation must be balanced for heat retention for year-round comfort, as they experience extremely cold winters and short, cool summers. This zone includes Alaska and the far northern regions. Homes in this zone require heavy-duty heating systems designed specifically for sub-zero temperatures. Oil furnaces, propane systems, or even wood-burning stoves are often used in remote or off-grid areas. Homes must be super insulated with airtight construction to withstand sub-zero temperatures. Another aspect of the climate zones to mention again is the difference between the dry and moist regions. In the dry desert regions of the western U.S., such as Arizona, humidity and latent load are not issues. This is why for equipment sizing, the guideline of Manual S, it allows for a system that can be up to 15,000 BTUs over the calculated load. This means it's okay for a system in a dry climate to be a little bit oversized because you don't have to worry so much about removing moisture from the air. In contrast, in humid zones such as the moist regions along the East Coast, choosing the correct system size is crucial because humidity control is a major issue. An improperly sized system will not remove enough humidity, therefore leading to discomfort and potentially mold and moisture problems indoors. Each climate zone has distinct heating and cooling needs, and HVAC designs must be tailored to meet those requirements efficiently. Whether it's ensuring proper cooling and humidity control in the hot, humid zones, or focusing on heating efficiency and airtightness in the cold regions. Understanding the local climate is essential to creating comfortable, energy-efficient buildings. By designing HVAC systems based on climate zones, homeowners can optimize energy use, reduce costs, and improve overall indoor comfort. Thanks for tuning into our video, and if you liked it, make sure you hit the thumbs up below and hit subscribe to see more videos from our channel. We'll see you in the next one.